Lesson. So when we're talking about the two activities you had yesterday, you had chemical bonding. And that led to something called, ladies, you have late passes? Wait. If you're coming into this class now, you're late. Go get a tardy pass. Go get a tardy pass. You can't be here without a tardy pass. We start class at 8 o'clock. So, I can't hear you. It's 8:04. So chemical bonding. Chemical bonding is what we talked about. We talked about elements. There are elements on the periodic table. You know what? Let me, is this connected? I wonder if this is connected. All right. So instead of drawing another periodic table, sketching one out, I just went and got one from the internet. What you see here, all the elements that we have to discuss, these are all the known elements to humans anyways. Who can name for me the elements of life? Anybody know the elements that involve life? Yeah. Oxygen, that's good. So definitely oxygen. Before we go on with that, and I'm glad I could see there were some hands up. That's fantastic. But before we go on and look at, do you guys need me to use the mic? No. Okay. So before we go on with this and try to find all the elements of life, let's first discuss the idea that in the first 4 rows of the periodic table, it starts up there, pretty much ends here. These elements down here tend to be, there's a lot of radioactive elements, but the other big thing about the elements that are down below this line is they're very heavy, and they tend to be near the center of the earth. Excuse me? So if you think about the elements above here, when the earth first started to form, there was a big gas mass in the solar system, and it started to swirl, and gravity pulled it together. Where do you think the elements that are below this line, the very heaviest elements, where do you think they ended up? Under the ground, in the center of the earth. The elements above it ended up being above on the surface of the earth. So if life was going to start on the surface of the planet, where do you think you would find the elements that life depend on, the elements that make up life? Where do you think these elements would be? In the first 4 rows or below? First 4 rows. So the elements, how can I help you? Do you have a tardy pass? All right, so the first 4 rows of the periodic table are where we're going to find those elements of life, the elements that make up life at the very beginning of life, right? These elements have to be in the first 4 rows. And so as you see, oxygen, someone mentioned, is correct. That would be one of them. Can someone mention some others? Carbon is another one. Yes, absolutely. Another one? H2O, so hydrogen, 2 hydrogens and an oxygen. Oxygens are already been mentioned. Any other guesses before I give you what they are? Okay. So when we're talking about the elements of life, this is just kind of the last little bit before we go on to chemical bonding, is something called schnapps. It's the elements. What do you think those elements are? Schnapps. What are these elements, schnapps? What do you think? Yeah. That's right. Carbon. Then what? Hydrogen. Hi, where you have tardy passes? All right, go sit over there on that side of the table. Go sit on that side of the table. Take the tardy passes with you. I'll talk to you after class. We're in the middle of a lesson. Get out your notebooks and start taking notes. Nitrogen. That's right. Oxygen. What's the P? What do you think the P is? By the way, peroxide? Yeah, it's a good. I mean, you don't know. Peroxide's not an element, but yeah, okay. It could have been potassium, but potassium's a K. The symbol's K. You see it here. The P is over here. See it? So P, the nitrogen. It's actually the sulfur here as well. The oxygen, the I got nitrogen and phosphorus. So those are kind of the big elements of life. And so this is phosphorus. And then the last one is sulfur.
That's a long word for how you say it.
Isn't it though? And then it always sounds like there should be an F in there, I think. That's the advantage of Spanish, is that we spell things the way they sound, and that's not true in English. But that's in English just because we have so many different languages that influence English. Like you have the Germanic languages, Latin and Greek, and so there's all kinds. It is an advantage in English to have so many different influences. So schnapps. Those are the elements that every building block in your body is made of. Now, you should know that there are other elements that are important, of course, like chlorine and sodium, and usually they're ions. And you know, there's other elements like obviously iron, and calcium. And magnesium. You know, what do you call these? Magnesium, calcium, iron, sodium, potassium. What do you guys call these? Nobody takes some. You take them in a bottle. Anybody see them before? These elements. Vitamins. Yeah, you call them vitamins. These are vitamins. They help you do the things you do. They help in a lot of different ways. You can see that all of them, though, where are they?
You put vitamins.
No, jeez. Vitamins. All right, go sit on that side. Thanks. So vitamins, those are vitamins on the periodic table. So even though they're not the main component of the elements of life, these are the elements of life. The elements that sit on that side, will you? All the molecules that make up life are made of these. All right. All the elements that make up the molecules are made of these over here. Where the others are vitamins, they're very important to how things work. You take those supplements to help you keep going. All right. But of course, you don't take them in like that, right? You don't go and get a little yellow rock and that's made of it's pure sulfur and chop it up and eat it, and then you've eaten sulfur, right? That's not how you take in sulfur. By the way, sulfur is the reason that your farts stink. If you ever wonder why your farts stink. Your farts are made of something called methane, and we'll look at that in a minute. Did we made methane in this in this class, or was that the previous class? Did anybody watch the video that I posted on your Schoology? No one's watched it. Okay. You guys got to keep up, okay? If you're not reading, listen, let's do a little bit of reflection. Let's take a minute and reflect. The YouTube videos wait, what are you talking about?
Because I remember on your page there was a video, but I couldn't watch it. I don't know what it was about.
You can't watch it because
It said it's blocked by the school. Yeah.
You can't access it on your phone.
I could, but I wasn't thinking about it.
Okay, so you can't access it on your phones. If you don't have access on your phones, I don't know who doesn't. And you guys watch YouTube videos and Instagrams all the time. You can access YouTube videos. You can access their YouTube videos. There are lessons that, for instance, the last time we were here, we spent a lot of time on trying to figure out how to upload information to Schoology. So we didn't have a chance to go over a lot of the content that I wanted to go over that we're starting today. So I posted the lesson that the other classes were able to do. We were able to do this, what you see in that video that's on your Schoology with the other classes. So you should try to watch it. It's blocked on your school computers, I understand that, but you can access it through your phones. If you ever want to, you can sign up for Time 01ster. All right, hold on. Wait, stop. Take that off. Go sit on that side of the room and start taking notes. And you have a quiz. You guys have a quiz at the end of this about all this stuff we're covering. Go sit on that side of the room. Start taking notes. Go sit on that side. I don't want it. Go sit on that side of the room. I'll collect them at the end. Time 01ster at gmail.com. If you sign up for that YouTube channel, then that's the class YouTube channel. Then when I post any videos, you'll automatically get a notice of it. And you can watch anytime you want. In case you're absent, I post the videos like this one's being recorded right now. I'll post this one. I'll post it for you daily, okay? Anything we cover where I'm reviewing or explaining, it'll be posted there. So if you're absent or you missed something, you're late to class or whatever, you can catch up later. All right. So that's above. So you'll notice even the vitamins are above the first 4 rows. So really for as far as biology is concerned, the main concern we have are the elements that we find up here. Should just see this. Up here in the first 4 rows of the periodic table. The bottom 4 rows, really, life doesn't use those elements very much. And that makes sense since they're probably closer to the center of the earth as far as where they're found. They're more rare, they're rare elements. All right, so let's move on. To into the earth, we dig down as far as we can all the time. No, we cannot go into the center of the earth. The deepest we've got, I don't even think we've gotten into the mantle. We've gotten, but of course, it comes to us in the form of magma and volcanoes, right? And lava. Huh?
I stopped digging because it's too hard to dig it up, or just because it's too hot?
We can't reach it. It's too hot. It's too deep. We've dug pretty deep. I think it's been. You'd have to go and look up how far we've gotten, but no one's ever been able to dig through the crust of the earth. So we are, if you think of planet Earth, everything you know, including the oceans, you know how deep the oceans, how big, thick that is, right? Mountains, how high they are. So all of that is on the is like right here on the surface, on this white line. So there's a lot more that we can't see. We haven't been able to get through that white line. We don't even know. We have not been able to get through the white line. So the white line, you have to think of it like if you have an apple. You ever peeled? I'm sorry. Did you just come in?
Yeah.
Could you go on that side of the room? You have a tardy pass?
Yeah.
All right, go over there. Take your tardy pass. Go on that side of the room. Take your notebook out. Start taking notes. We have a quiz at the end of this. So quickly, hurry up. So if you ever peeled an apple. When you peel an apple, the apple peel, that's how thin the Earth's crust is compared to the rest of the Earth. So it's very, very thin. So yeah, we have not, and there's a lot of those elements. Most of the heavier elements are obviously deeper in the Earth's deeper in the Earth. Now, a lot of those elements do come up to their surface in the form of magma and lava. Obviously, I think you know that. So they do come up to the surface, but they're much more rare than things like oxygen, nitrogen, right? All right, so let's go on and talk about chemical bonding. You've talked about 2 different kinds of bonds, right? Covalent and ionic. All right, so because we weren't able to get through a lot of material last time, we're going to have to do some of that review today. If you would have had a chance to watch the video, you would already have seen this. So if you get a chance to watch the video, I would, since we go into more detail in that video. So when you're talking about these elements, atoms, as we've discussed earlier, and you've done an asynchronous activity on atoms, you know that atoms have a positive charge in the center. They also have neutrons in the center, but the smallest atom doesn't. The smallest atom is called hydrogen. By the way, they get bigger. They go from small to big. So the small atoms are at the top. The big atoms are at the bottom. Pretty much what I just said earlier about they're heavier as well. And the smallest also are at the left, and they move towards the right. So the very smallest atom is a hydrogen, and it only has a proton, a single proton. A hydrogen ion is just a proton, just one positive charge. There's no neutrons, no electrons, it's just a positive charge. But if the hydrogen is neutral, it has how many electrons? Say what? Without an electron, it has a positive charge, right? It has one positive. You see it there, yes? Yes. All right. So if it's going to be neutral, that's blurry, isn't that blurry? I should focus that. If it's going to be neutral, how many electrons does it need? One is correct. It needs one electron to be neutral. So that's a neutral hydrogen atom. Now, we usually draw it like this with an orbital. This is called an orbital. So this is the path the electron takes. If we were going to draw it accurately, we would draw it more like this. The electron's path is not predictable, but this is called the cloud model. It's not very useful for us to discuss chemistry. So we don't really use it a lot. In physics, you use it a lot, and you could do it in advanced chemistry. But at this level, when we're talking about electrons, it's more useful to think of an electron going around the nucleus of an atom in a path like the moon going around the sun. I just want to make sure you understand that's not how an electron goes around an atom. And that has implications. It has some really strong implications and consequences that the electron actually travels like this in a fairly unpredictable path. So that's a hydrogen atom. There are two rules to atoms, two things atoms have a tendency to go towards. Sort of like you pull a ball on at the top of a hill, what do you think is going to happen? It's going to roll down. No one here imagines that if you put a ball at the bottom of the hill, it's going to roll up. Is that correct? All right, so there's a tendency for things to happen, right? There's a tendency for things to happen. And there's two tendencies for atoms. Two things that atoms are always going to do. It's just going to happen. Just like if I pushed you out a window, you're going to fall, right? There's this reality, this tendency of things to happen. So there's two of them. And the first one is that atoms tend toward neutrality. So they tend to try to be neutral. So if they're positive, they're going to try to get to zero. If they're negative, they're trying to get to zero. They're always trying to get to that zero. They're trying to balance the what and the what. To get to zero, they're balancing what? And positive and negative. Right, you got it. They're balancing positive and negative. So just like we said, if there was a positive, it's going to pull in an electron. If there's a negative, it can't pull in protons, by the way. It can't pull in a proton. The protons are set. So all it can do is pull in electrons. But they tend towards neutrality. The second thing is atoms tend to a full octet. I shouldn't use that word. A full outer shell. So when you think of atoms, you have to think of them as onions, where you peel an onion. You peel a layer off an onion, what do you got inside? Another layer. You peel that layer, you got another layer. Well, atoms are that way. Each layer we call a shell. See, kind of like nesting dolls. You ever seen those little nesting dolls? You pop open a doll, there's another one inside. Well, let's take a look at one of these atoms. Let's look at carbon. Carbon has 6 protons, 6 positive charges. Oh, I thought you had a question. So carbon has 6 positive charges. And the very first shell that carbon has can only hold 2 electrons. So then it starts to fill in its outer shell, the next shell. Its next shell, it starts to fill in. How many electrons do you think I have to put in here? Who said 4? Yeah, 4. 2 are what are already in there. There's 6 positive charges, so you expect how many? Because in rule number 1, how many do you expect? 6. So you expect 6. There's 2 already taken up. So then, by simple mathematics, you'd expect then that there'd be 4. So there's 4 electrons in the outer shell of carbon. Now, there's an interesting piece here. At this point, both hydrogen and carbon are neutral. That's fine. That's great. But neither one of them have a full outer shell. The inner shell can only hold 2 electrons, max. So that shell has 2 max electrons. So it has already 1. How many does it need to have this second rule? Remember, it's what is it? What are the 2 rules? Number 1, is hydrogen neutral? Yes, it's neutral. So rule 1 is done. What about rule 2? Does it have a full outer shell? No, it does not. So it needs that. How are we going to get that done? Here's this carbon. Carbon can have up to 8. So you can only hold 2 in the first shell. This is the first shell. But in the second shell, it can hold 8. That's why we call this rule, we call this the Octet Rule. Because most of the shells of an atom can hold 8 electrons. It's only that inner shell that can only hold 2. So hydrogen, helium, lithium, those guys, when they're dealing, or hydrogen and helium really, are when they're dealing with their outer shell, it really is only 2 electrons you have to worry about. But the rest of them is 8. So there's up to 8. So how many electrons does carbon need? Well, look, it has 4 in the outer shell. It has 4. Do you see them? Let me draw them in circles. This is 1 in the inner shell, 2 in the inner shell. The inner shell's full. We're done. There's 1, 2, 3, 4 in the outer shell, but it can hold 8. So how many does it need? 2 more would make it 6. 3 more would make it 7. It needs 8 to be full. 4. It needs 4 more. But if it took on 4 more electrons, what would its charge be? They wouldn't be neutral. How does an atom do both? That's the question. So let's go ahead and take a look at an example in our lives. Let's say you had $50,000 and you needed $100,000 to get your business going. It's the business that you want to make happen. You have a dream business, you know it can make it happen, but you only have $50,000, you need $100,000. Then you meet someone. That person has $50,000. And they want the same dream you do. What do? You become a partner, right? You become co-owners, right? Yes? Well, who owns the business if you do that? Both of you own it, right? And so we call that, in this case, a bond. We're going to call it a covalent bond. Covalent bond. The co means sharing. Valent is the electrons, the valence electrons. So let's go ahead and do it. We have carbon. I'm only going to put the outer shell electrons. I'm only going to put the outer shell electrons. Is that okay? All right. There's carbon. There's 4 electrons. It needs 8. Here's hydrogen. It needs 1. They can share these. They can share these two. And that's a covalent bond. You've just made a bond. Very strong attraction. Those of you that did the activity yesterday the way you should have, you saw that happen. So is carbon, hydrogen's done. Hydrogen is neutral because it only has 1 electron, although it's sharing 2. And it also has 2 electrons. So it has the best of both worlds. Hydrogen is set. Is carbon set? No. How many more does it need? 3 more. So we can go ahead and use hydrogen just for this example. And what we get, if you use up 3 more hydrogens, each with 1 electron, now everybody's happy. And you have this molecule. This is now a molecule. A molecule, in fact, is a partnership. A molecule is a partnership between atoms. It's a very strong partnership. Molecules can hold themselves together for millions of years. Right? So some of the water you're drinking was peed out by dinosaurs millions of years ago. That water's been around for a long time. Methane has been around for a long time. So some of the methane that we pull out of the ground is the rotting dinosaur bones and skin and ancient trees and forests. So anyways, this is called methane. Those of you that have gas stoves, burn this in your gas stove. This is the gas that you fart as well. Rotting organic matter makes methane. So when you die, your body will be decomposed into methane. When you eat food, you digest it, part of it gets turned into methane. So that's the gas that you fart out. Methane has no odor. No odor at all. The stinky part is the sulfur from the proteins that are still in your intestines. It's your poop that's the stinky part. Methane is the gas that's produced from the breakdown of the organic material. So that's a molecule. You don't have to add. That's the really cool thing about carbon is you can take those 4 bonds. You don't have to add 4 hydrogens, and they're all the same. How'd that go? All right. Thank you. Appreciate you. See, you don't have to add 4 hydrogens. You can add 2 hydrogens, right? What else do you think you can add? You could, then you'd have methane again. Or you could, what you could do is you could add another carbon. And then that carbon could have a hydrogen over here. Or maybe it has another carbon over here. Maybe it has another hydrogen here. Maybe you got something like this. Isn't that crazy? The molecules can get very long and big. So what's cool about carbon is it can form chains. It can form chains. That's number 1. It can branch. Carbon can branch. It can form circles. cyclic things. So for instance, it could do something with oxygen. It could do something. I'm just going to put just every time you see the two lines come together, bless you, there's a carbon there. So there's a carbon here, 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 and here. So every time you see two lines come together, there's a carbon. This is much easier than trying to draw all that mess, isn't it? The lines are the electrons being shared. So every time, and you don't see the hydrogens, there would be hydrogen sticking out everywhere. So there are many models of drawing this. This is very useful. It's called, just using the sticks and the lines is very useful. Let me draw this neater. There's 5 carbons in this molecule. You don't know this molecule, but this molecule is called ribose. It's a sugar. You could have something that has, you can have that same oxygen, kind of do something like this. Oh, I need a different tip to my eye pencil. The screen is too slippery. Come on. There's no reason for that to happen. So this one has 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5 carbons, and 6 carbons. This is a 6-carbon sugar known as glucose. All right, you know glucose, don't you? And so there's a lot of them, and of course you can put them in a very, very long chain, and you can do all kinds of interesting things. And what you can do is you can actually have them twirl around in a spiral if you'd like. Or you could do 2 strands. You can do 2 strands, and you can form something like this, and you can call that DNA, right? Right. So carbon can be put together in so many different ways. It's an amazing. You can change its length, its chains. It can form chains. You can form branches, circles, and the fourth cool thing about carbon is it can be any number, any length. It could be short, like methane, or it can be long, like DNA. The chains are, there's really, bless you, almost no limit to the various shapes, sizes, and components. Does that make sense? Mm-hmm. All right, yeah, question? Where? Here? Yeah. All right. Everybody got it? Remember, this is being recorded. Anything you miss, I'll post it online. You can catch it when you get done. So now that we're all here, let's go ahead and be a little reflective. We're going to go on and look at another way of doing things, which is the ionic, forming ions, which you guys have done already, right? You've done this, ions and covalent bonding. But I'd like to take a moment now that everyone's here and be a little reflective and think about what you should have done up to this point. So at this point, you should have completed the in-class assignment yesterday. That should have been done. If you haven't done that, I don't know what to say, but it should have been done. At this point, all work should be uploaded All right, we can look at that, but I don't think it is, but we can look at it. I might have made a mistake, but I mean, it happens. We can look at it during lunch or something if you like. I'm not assigned 4th and 6th. I'm also going to be here after school. There's going to be a bunch of neurosurgeons coming in. I sent it to you in Jupiter. Really impressive group of people, but only the first 30 kids are going to be able to participate. So the first 30 kids that actually show up are the ones that get to participate. So you'll have to sign up. You can sign up at 3 o'clock. With me, obviously. It'll be in here. Neurosurgeons, they do brain surgery. They're brain surgeons. So all work should be uploaded to Schoology at this point, right? That's the expectation. The expectation is that you're taking notes. You're taking Cornell notes. The expectation is that you're reading your chapters, your chapter reading. And notes taken. Where would you find your chapter? That's a good question. Go ahead, someone answer that question. Where would you expect to find your chapter reading? In the syllabus, and I'll post it. I'll post the syllabus in Schoology for you, and I'll also I'll post the links to the book. It's with the syllabus. The syllabus and the chapters are all together online. Also, you could take a book if you'd like to take a physical book and take it home with you. There's about 2 chapters a unit, so you can read it at your leisure. But when kids tell me they don't understand, what do you think is going to happen when you come to me and you say, I was late, I missed something, I was absent, I missed something. What do you think I'm going to say to you? Does anybody guess?
So back to the book.
Well, yeah, I'm going to ask you, okay, sit down. Show me your notes from your chapter. Show me the notes from the videos that I posted. Right? Because I understand having to be late and having to miss. That's normal. That happens. But you have to compensate, right? There has to be, you have to find a way to make that up. It can't be on me. You can't expect me to redo an hour's lesson. Does that make sense? Class starts at 8. You can't expect that the whole class is going to go back to the beginning and start everything again because you came in 20 minutes late. Does that make sense to everybody? So you guys have to compensate for it somehow. So take notes. All right. And lastly, for this week, what's the one thing you have to should have done already? It's due today. That is going to happen in preparation for something that's going to happen tomorrow. The pre-lab. You have a pre-lab that you need to have read and taken notes on. And those notes are due today on the pre-lab. So you should have read the pre-lab after the assignment yesterday, and after we're done talking about this today. You should have a better idea of some of the stuff that's going on in there. You should know what you should have any questions. What I'm looking for in your notes are, what questions do these kids have about what's going on? I want evidence that you've read it. You can revise the notes based on your reading, based on the class notes. So you guys can add and subtract from that material. All right. So that's kind of what you should have done at this point. That's kind of, if I were reflecting, this would be a list that I would come up with of things that I should get done. Also today, if you're interested in neurology or being a physician, today these people are the top. Do you understand neurosurgeons are the top of dogs? Do you understand that? They are the most elite surgeons. I mean, you would think cardiovascular surgeons because you're operating on the heart, but neurosurgeons operate on the brain and the spinal cord. It's the most delicate work that there is. one mistake and someone's paralyzed or has brain damage or dead, right? Just a slip of the finger, a twitch. And it's very delicate surgery. So these people are highly trained. They spend 10 years after medical school in training. So this is something, if you want to know about being a physician, about being a surgeon, these people are the people you want to talk to.